Uh,
Yes.
Okay, thank you so much. Well, good afternoon, ASCE North Carolina Eastern Branch members and guests, should there be any. I'll speak to you briefly about the topic of combined sewers. This particular presentation is titled A Decision Analysis Systems Approach to Eliminate Combined Sewer Overflows, and it was accepted into presentation at the 55th International Conference on Water Management and Modeling. This occurred back in March 2022. And if you recall, we were also in the midst of the COVID pandemic. This presentation will focus on the collective approach of local leaders, from elected officials to designated staff, as they embark on a pathway to successfully comply with two active NPDES permits. As background, I earned my PhD from Indiana State University in construction management. I earned my master's in civil engineering from Norwich University with an emphasis in water resources. I also have an MBA. I'm a former naval officer with 35 years of relevant national and international experience. And for reference, I was selected by the Alabama State Port Authority to travel to Cuba to assess all of the country's major port and rail infrastructure. And this was in advance of the completion of the Panama Canal widening. And that information was used to facilitate a public-private partnership that involved the Port Authority and a private sector business. This body of work was done in Albany, Georgia. Albany, Georgia is a city in the southwestern part of the state, and it has approximately 75,000 residents. Unlike many remaining cities in the United States, Albany has a combined sewer system, and some of those sewers actually date back to the early 1900s. And what was interesting to note is that even though those sewers date back to the 1900s, there were a selective group of engineers who were planning for the future. They actually stubbed out, and ran laterals so that at some point when this process was taking place, it would really facilitate a more feasible separation project. In order to be successful, there was a requirement to have seamless visionary leadership. As you can imagine, projects of this cost magnitude have the potential to separate communities. Storm and sanitary sewers are underground. They're not something that's seen every day. So there's not necessarily an understanding among taxpayers as to why so much money should be allocated to something of this magnitude. Information was developed and presented in a series of checks and balances, such that there was buy-in from the various community leaders. Ultimately, this 30-year capital improvement program had short-term as well as long-term goals. And when I talk about short-term, I'm referring to uh, years 0 through 5, and then long-term would be years 5 through 30. And the primary distinguishing criteria for that is that the two permits provided the city with a 5-year timeline to comply. Some of the steps that were taken were first and foremost problem recognition. As indicated before, although these are unseen infrastructure components, they are viable components to a sustainable community. There was an independent peer review. TEI was retained to perform a number of services on behalf of the city of Albany. There was an NPDES permit compliance. And in addition to just permit compliance and separating storm and sanitary sewer, the city of Albany made a decision to provide at least a 10-year level of service for stormwater events. So for all of the impacted areas, there was a focus on not just separating sewer, but making sure that there was adequate capacity to convey a 10-year storm. And finally, you should recognize that this also provides a return on investment for the environment. The environment is viewed as an independent entity, and the goal is to be responsive and ensure long-term sustainability and viability. As it relates to goals, there were two methodologies used after the permits were received. Initially, before the permits were written, the city had to begin an evaluation process so that they could ensure they met the 5-year criteria. And in that initial evaluation process, they assumed that they would be required to separate 100% of all storm and sanitary sewers. For those of you who have an interest in understanding project costs, there is a diminishing point of return when you reach low density areas and you're trying to achieve 100% separation. So the permits were written from the state in that the average separation was only 85% requirement. So from that, once they received the approved permits, the focus was achieve 100% separation in high density areas, and then focus on 85% separation in the low density project areas. And they would use a 30-year CIP to make this a viable initiative. In terms of the environment, these combined sewer overflows discharge into the Flint River. And the intended use of the Flint River is for fishing and water recreational purposes. Due to the current amount of untreated waste that discharges into the Flint, one will have to travel miles downstream in order to use the river for that purpose. Regulatory compliance. Agencies such as the Georgia Department of Natural Resources and Environmental Protection Division, they're currently managing water quality through the permitting process. Across the nation, the discharge of untreated combined sewer overflows negatively impact the receiving waters. So this is not unique to Albany. As indicated earlier, Albany had 2 expiring permits. Georgia EPD reissued those permits with a 5-year requirement to comply. Within Albany, there are 8 discharge points, as well as a publicly owned treatment works. The treatment works, or wastewater pollution control plant, is permitted separate from the 8 discharge points. So each of those 8 discharge points serves a drainage basin. So there's 8 basins throughout the city that collect and transport our combined sewers. To give you an overview, as most of you know, there are 2 ways to collect and transport sanitary and storm sewers. Historically, communities used the combined sewer approach. This was an economical way to develop and build cities. But the downside of that is that during high rain events, there was not enough capacity to carry the flow to the wastewater treatment plant. And so we end up with bypasses of untreated waste. And then beyond that, during heavy rain events, when the water or the waste did arrive at the treatment plant, there was not capacity to treat all of it. So there was an additional overflow at the plant in and of itself. Municipal separate storm sewers are normally, that regulation is applicable to municipalities, and they are required to separate storm and sanitary sewers, but that method is more costly. The city of Albany retained an engineering firm called Constantine Engineering. Constantine was purchased by Adura, and their task was to develop a 30-year capital improvement program that would address the needs of the NPDES permits. And again, their work started in advance of receiving the approved permits. My firm was hired to conduct a peer review, and during the peer review, we identified approximately $30 million in savings, where the city of Albany did not have to expend those funds. The modeling software platform that they used to evaluate it was PC Swim. In addition to doing a peer review, we were retained to complete a community development block grant through the mitigation program for phase 1 and phase 4 of the 8th Avenue Basin. There were two separate constraints that the city placed on us. When we were evaluating the model for compliance, we were told to assume that all calculations, all assumptions, all analysis, all model results were accurate. We were reviewing it simply for compliance and conformity. And even though that limitation existed, we still identified 10% savings. After that, when we were awarded the contract for the 8th Avenue Phase 1 and Phase 4, they wanted an engineering seal confirming that 100% separation had been achieved. As with all engineers, we are always cautious when such a constraint is placed on us. So what we did in this instance, once I realized that they had used PC Swim for the initial evaluation, I contacted Computational Hydraulics International. And Computational Hydraulics International, or CHI, is a firm that actually developed PC Swim. And they were intrigued by the process of working with a small firm. So they provided me with a team of engineers, two PhDs, and an engineer with an advanced degree and over 20 years of experience. So collectively, we were able to run the model again, and we identified some additional pipes that needed to be installed to achieve 100% separation. And from that perspective, I was then comfortable sealing such a document. And this is just an analysis of that overview process. The Adura final report was developed to establish a comprehensive overview and an ultimate solution to the City of Albany's problem and requirement to comply. And as indicated previously, instead of achieving 100% separation basin-wide, they will achieve 100% separation for the high-density areas, and then on 85% separation for low-density areas. There's a need to update aging equipment, and these are just two examples. Rotary drum thickeners are used to remove excess moisture from the sludge. That reduces hauling costs, and it makes it more efficient when they get to the land application phase. New thickeners reduce that. We just indicated hauling costs. Also, clarifiers. New clarifiers will increase the efficiency with additional removal of solids. Lift station upgrades. The city has a number of lift stations. Some of those are simplex pumps, but for the most part, you want redundancy. So they went through and installed duplex pumps. They evaluated and reevaluated flows because additional development had taken place since initial construction. So some of the pumps were under capacity. And by taking these approaches, they were able to greatly reduce overflows due to malfunction or undersized equipment. In regards to construction in municipal areas, this is just off the Broad Avenue bridge. There are areas where it seems as if it's an urban environment, but there are also areas where the sewer runs along streams and creeks that are in floodplains and floodways that are not heavily populated. And so this just gives a perspective of the different construction areas. Inflow and infiltration. We recognize that water, unfortunately, enters the system at various points. At these points of connections, whether you have a damaged manhole or a cracked or broken pipe, there's opportunities for inflow and infiltration, and that needed to be reduced. And one of the ways to reduce it is using methodologies such as in situ form. And we'll also look at some additional alternatives as we move forward. Pipe bursting. One of the things that stands out in this slide is that you can do pipe bursting, you can do point repair, or you can install entirely new lines. The line on the left, point repairs is not an option. It needed to be replaced. And if there's not a need for substantial upsizing, pipe bursting becomes a viable alternative. One of the things with that is that if you look at the coefficient of friction that takes place with high density polyethylene, you can achieve a increase in flow by slightly upsizing the pipe that may accommodate whatever growth is taking place in that area. Additional constraints that occur in municipal construction. In this instance, there's not an opportunity to slope the sides. This increases the risk of the trench collapsing. So we want to be safe at all times. There's no encouragement to take shortcuts or save money when we talk about the installation within a municipal area. Regardless of whether municipalities are required to comply with OSHA requirements or general safety concerns, our specifications was written that was the minimum criteria. So in this case, they have double trench boxes indicating that this trench is approaching depths of 20 feet or more. And again, safety was always a priority. This slide is an example of a sustainable City of Albany project. And this is actually the flood of 1998. I was a young engineer assigned to this project. So there were two major floods. 1994 was a 500-year flood. It was declared a national disaster by President Clinton. 1998 was a 100-year flood. So within a 4-year time period, the city was devastated. In this instance here, those rods sticking out of the ground are actually well points where we're lowering the groundwater level such that the tie-in into the lift station 7 can be facilitated. There were some mitigation measures that took place here. Number one, the deep sewer, our trunk sewer, instead of going back with reinforced concrete pipe, we went back with high density polyethylene from manhole to manhole. The first thing that did was reduce inflow and infiltration opportunities, but now it eliminated the benefit of being able to tap into that trunk line. So the mitigation measure that was ultimately approved by FEMA's engineer of record, which was Dewberry, was the installation of a shallow sanitary line that the communities, such as the house just to the left of that excavator, could tap into. Earlier, we spoke about point repair. In the slide that we saw then, point repair was not a viable option, so we recommended pipe bursting. In this instance here, point repair is an option. So this is an example of where we cleaned and videoed the lines, identified particular breaks, and then made recommendations for economical repairs. And keep in mind, during all of these processes, it was required to educate the decision makers such that there were no surprises. They understood the scope, they understood the schedule, and they also understood the budget. And as I'll speak to later in the presentation, this methodology needed to be consistent such that when elected officials changed seats and whether the board was led by Democrats or led by Republicans, a reasonable person would say, yes, we need to fund the completion of this initiative. We value return on investment to the environment, and we want to ensure that we comply with the permit requirements. TEI notes that the best opportunity to implement cost-effective measures is at the beginning of the project during the planning and design phase. We have noted that city staff have completed some relevant changes throughout, I would say, the last 50 years. There has been a concerted effort for the city to make incremental improvements. They were always working towards separating storm and sanitary sewer, but there was never an impetus, such as a consent decree, to really push them to have a funding mechanism to address these needs. We made recommendations to explore collaborative cost-saving approaches because sewer separation is really the most expensive method of eliminating a combined sewer. It's not the only method, but it is its most expensive method. We evaluated the report based on Environmental Protection Agency's 9 minimum controls for the correction of combined sewer overflows. And I just read through those briefly. Proper operation and regular maintenance programs, maximization of storage in the collection system, review and modification of pre-treatment requirements, maximization of flow to the public-owned treatment works, elimination of combined sewer overflows during dry weather, control of solid and floatable materials in combined sewer overflow systems. Number 7, pollution prevention programs to reduce contaminants in the CFOs. Number 8, public notification. So if there's a spill, there's a requirement to issue a public notice. That public notice serves multiple purposes, but one is to let people know of the hazards that exist in the vicinity of where they are. And one, they can anticipate that the conditions will be safe and they can return to their normal processes. And number 9, monitoring to characterize CSO impacts and the effectiveness of CSO controls. Number 9 was actually a requirement that was contained in both NPDES permits. The city of Albany has to continue to implement monitoring and analysis such that there is a validation of the measures that are being put in place. In inline retention, this approach will maximize storage by adjusting overflow structures so that the city could take advantage of the system capacity. Oftentimes, you'll hear conversations about weirs, and initially, young engineers may not understand what the ultimate goal is, but the purpose of the weir is really to slow the flow and take advantage of the storage capacity. That's one of the purposes, rather. Offline retention. A tunnel is an example of offline retention. These devices provide additional system capacity that can be used to reduce combined sewer overflows. This particular photograph was taken inside the City of Atlanta's South River Tunnel project. This was a $110 million project that was part of the city's response to its consent decree. This particular tunnel that I'm standing in was over 9,000 feet long, 14 feet in diameter, and connected to a 45 MGD pump station. That's a lot of waste. This work was accomplished via the Atlanta Services Group, which was a joint venture between SL King, EDT, and Jacobs. In addition to the city of Atlanta, there are other municipalities that have offline retention, such as Elizabeth, New Jersey, Grand Rapids, Michigan, and San Francisco, California. So when we were communicating with elected officials in Albany, Georgia, we were able to show them direct and relevant instances of how other localities manage their processes. So once they were educated on what technology existed, they could then feel more comfortable making informed decisions as related to their area of responsibility. Green stormwater infrastructure. This is a resilient approach to stormwater management, and it's the Fourth Ward Park in the city of Atlanta. This park is actually designed to flood. It can be used for recreational purposes during low water events, but in high water events, it floods, and once the flood subsides, it's cleaned and returned to use as a park. Prior to taking this initiative, this area of the community was blight. It was unmaintained. It was not usable, but this was a win-win situation for the community as well as for the city of Atlanta. This is a local example in Albany, Georgia, of green infrastructure utilization. Richard Marbury is my mentor, and Richard designed this such that the practice field floods and forms as a retention basin, serves as a retention basin. It's not evident in the photo, but if you look along the left, that's actually a constructed berm. And then farther to the left of that berm is the Flint River. This is the lower campus of Albany State University. And during the floods of 94 and 98, this campus received substantial flood damage. If you recognize that part of an engineer's responsibility in terms of designing projects is also to mitigate future losses. In this instance, one of the things that FEMA approved in terms of mitigation was the expansion of the Albany State campus across the street, further from the Flint River and on high ground, such that those investment of taxpayers' dollars were not subject to continued and repeat flooding. This is another example of green stormwater infrastructure within the city of Albany. This is Mary Young Cummings Park. And in North Carolina, this small first flush pond would be called a forebay. And the purpose of that is to collect the first 1 inch or so of runoff, which is where most of the pollutants reside. The larger pond serves two purposes. It's lined such that there is a minimal water level that is sustained for aesthetics. Then you see freeboard. The freeboard is for the purpose of minimizing flooding, and it forms as an opportunity to remove the peak flow from the storm event. Prior to the flood of 94, all of this area was house upon house. So the lowest lying of those areas were bought out, and that's what was converted to the forebay and then the dual purpose pond. Another method of green stormwater infrastructure is actually property acquisition. If you look along the Flint River, there were three entities: the City of Albany, Dougherty County, and the Southwest Georgia Regional Commission, where they acquired properties, removed the structures, and then that space was left as green space. The permitting requirements that were in place in Albany many, many years ago did not recognize the floodplain or the floodway. So construction was allowed to take place, and there was no requirement to have a finished floor elevation at least 1 foot above the 100-year base flood elevation. Within this community, after the floods of 94 and 98, there was a lot of conflict because people wanted to rebuild their homes, but they could not rebuild the way things were. They had to meet the new building code. And the new building code was base flood elevation plus 1 foot. And even that elevation would not guarantee that there would not be future flood damage. Because as you notice, our seasonal events are becoming more violent. There's more rainfall, more intense and more frequent events. So it's forcing municipalities, not just Albany, but municipalities across the country to revisit the way they permit structures for the residents. We often hear the term piping the ditch. That's transporting stormwater either in pipes or large culverts, but that's very expensive. An alternative way of moving water is through open ditches. And this is just an example of channel flow, open channel flow in Northwest Albany, and how they are routing or connecting ponds to manage stormwater runoff. That really concludes the basis of my report. And I would just like to remind you that the two active NPDES permits had a 5-year compliance criteria. So June 2025 was the deadline for compliance. And as such, the city has received approval for a compliance extension. They're actively operating on an extension, an approved extension, but they have full intent to fully comply with both permits that were issued to them. With that, I'll open the presentation up for discussions, comments, or questions.
Hey Joseph, this is Brad Smith. Can you hear me?
Yes.
Appreciate the presentation here. I appreciate how you um, tied I, a lot of ideas about how to manage stormwater as a whole into the presentation there, and not just ways to reduce um, combined sewer overflows, but we've obviously, as you mentioned, we've got more frequent and larger rain events to deal with. Going back to one thing you mentioned, you talked about finding savings of $30 million dollars in the initial proposed separate storm sewer design. What types of efficiencies were you finding there? Was that referencing specifically like the pipe bursting
Okay.
rehabilitation, that type of thing, or were you finding other methods that helped save some cost there?
That's a good question, Brad, and one that received a lot of interest from the regulatory bodies. And it consists of multiple responses. One of the things that was recommended was uh, reducing the peak flow, right? So in stormwater, as you know, if you can have a pond that can reduce the attenuation of the impact, then your downstream pipe size can be smaller. Within Albany, there is a perception that all ponds are bad. And the reason for that perception there is that there was no active maintenance program. So yes, it's bad if you don't have someone to remove the trash and debris, if you don't have someone to mow it, etc. And we were not really able to move them off of that position statement. So that part of the recommended savings was not actively pursued, but it was presented. The next opportunity for savings, and this is where the cost really increases. If you recall, Ordura's plan was based on achieving 100% separation in the low density and high density areas. Their plan also involved a wastewater treatment plant being sized to accommodate 100% of the flow. But when you start separating storm and sanitary sewer and reducing and if possible eliminating inflow and infiltration, you don't have as much flow going to the plant as you once had. And if you recall, I indicated there were 8 discharge points. So that's 8 basins that contribute to the river. In addition to that, there's an overflow point at the wastewater treatment plant itself. And the design included a 60-inch force main. It included a pump station with the capacity to move that volume of water. And it included a chlorine contact basin to be built at the discharge point of the existing wastewater treatment plant. And then finally, there was a projected growth based on census data that was not quite accurate. So in essence, Albany was not continuing to grow in population. Albany had actually stabilized and in some instances had a very slight negative decrease in population. So there was no need to expand the plant based on what the theoretical growth patterns were 10 to 20 years ago, because there was new census data available. When we start talking about such initiatives, and I'll say this, it's a very sensitive task to take when you're conducting a peer review. Number one, you want to be respectful of your fellow engineers. Number two, you want to be responsive to the client and the residents. So I found that there was a way that a small firm like mine could be successful in those aspects through open communication and by explaining things that while Ordura did recommend 100% separation, that was not necessarily an error or omission. That was based on the assumption that they had to achieve 100% combined sewer separation from stormwater. But the permit, which was written after that report, only required 85% in low density areas. And so by being able to explain that methodology, we could substantiate a 30 million plus dollar savings to the city. And that was the main way that, Brad, that we were able to substantiate and feel comfortable making such a recommendation to them.
Gotcha. Very good. Thank you.
Okay.
Yes, sir. This is Ken Polig. Uh, thank you. Great talk here. I do have a question though. Maybe you can talk a little bit about. I'm assuming there's going to be positive, really positive, benefits to the receiving. Essentially to the wastewater treatment plant. Essentially can you talk about that? Like how was there kind of what was there a measured overall annual flow decrease or INI decrease? Do you have any numbers or maybe percentages about that?
Well, that's a good question, Ken. And one of the things I say is that monitoring was an active part of the permit compliance. The city did not engage us in the monitoring. One of the things that's different in Georgia than in North Carolina. So in North Carolina, a county would not own, Wake County, for example, does not own any construction equipment. Wake County does not have any design engineers. They don't have surveyors. They don't have construction inspectors. But the city of Albany and Dougherty County have access to their own design team, their own surveyors, their own construction inspectors, and they have their own equipment. With that, the maintenance and the monitoring, collections of sampling that can substantiate your question as to the return on investment achieved by such a separation. That data was collected and owned by Albany and only communicated or shared with EPD, the Environmental Protection Division. Now, in 8th Avenue Phase 1 and Phase 4, when we wrote that community development block grant, one of the things we had to speak about was the opportunity to return the Flint River to its intended purpose. What we use as defining criteria was the NPDES permits in and of themselves, such that if the city met their requirement, they would achieve compliance. But we did not have access to actually see those numbers. And quite honestly, I'm very interested in that data, not only from an engineering perspective, but just from research, right? It's a great opportunity to actually publish. It's an opportunity to determine what methodologies work and to what extent they are effective. So again, Ken, very insightful question, but unfortunately, we don't have access to the data.
I've got another question for you, Joseph. This is
Okay,
Brad
perfect.
Smith. When the proposed MS4 system and when separating the previously combined sewer, is it installing all new sanitary sewer line and all new storm sewer line, or is the existing CSO or the existing combined sewer system being retained and rehabilitated to act as a sanitary sewer, and then there's new storm sewer going in, or vice versa, or a mix, depending on the situation?
That's a good question. So it was a dynamic process, and that was one of the benefits of having a robust model such as PC Swim. We could actually propose alternatives. We could check and see if the existing pipe could best serve a purpose of carrying sanitary sewer, or if it was large enough, it could carry storm sewer and we just remove sanitary off of it. If it wasn't large enough, then it would become a primary sanitary sewer and we would install new storm sewer. Keep in mind, with the way PC Swim was set up, each drainage inlet had its own sub-basin. So we could determine how many CFS would that inlet need to carry. Well, that's how we size the inlet. Then once we understand what the inlet capacity is, we can say, okay, well, what's the flow that that pipe need to carry? And depending upon what those numbers are, that's what determines whether the existing system could meet the need as a sanitary or storm, or if it could not meet either, then we would install new sanitary as well as new storm pipe.
That makes sense. That's very interesting.
Okay.
Would you recommend PC Swim as the modeling program of choice for this type of project in the future? Were there some deficiencies that you found?
Well, I did not find deficiencies, and I know that there are other software programs out there that could do this type of work. The decision was made before we arrived on the job, and since the choice was PC Swim, we wanted to have continuity. And the benefit of having continuity is it removed an opportunity for someone to say, well, I don't know if that answer is correct because now you're using a different software than what was used during the initial analysis. So for those purposes, even though I was not a proficient engineer in PC Swim, I was motivated to go to the source because I wanted continuity and I wanted a viable report that could withstand scrutiny. And for having such a conversation with the developers of PC Swim, they were motivated to make sure that whatever answer was generated could be substantiated. And that's why they brought such a highly qualified team to assist me in such an endeavor. But again, I became very confident. I had not used PC Swim, but after I saw how robust it was, how they could run the model, how you can make changes to pipe size, you can even enter variables into the pipe consistency, whether it's an RCP pipe or an HDPE pipe, what's the subbasing going to the inlet. And so it's able to handle all of these robust tools. So from that perspective, I had no opposition to it. But again, I'm aware of other software that exists out there. And I do know that there was a lot of conversation in the design community where engineers were saying, yes, I can design a system, but if I don't have input, if I don't have flow, if I don't have a dynamic process that can guide me, how do I have a level of comfort when I put my seal on something that is going to meet the criteria that have been outlined? So I would highly recommend a robust program if you're undertaking such an event.
Great. Thank you for the insight.
Okay. Tony, I see your hand raised. You're on mute. You're on mute, Tony. We can't hear you.
Can you hear me now?
Yes.
Okay, I come from a long history with on-site, and knowing that you're doing retrofit now, in your planning with new sites, do you think of eliminating big pipe and going to on-site? And on the stormwater side, I've worked with a large developer who has completely done away with curb and gutter, everything open ditch sections. Are you trying to educate users to do away with as much stormwater offsite as possible?
That's a good question, Tony. And part of the things that you're speaking about requires a cultural shift. And what I mean by that, in let's say 20 years or 30 years ago, when you looked into a drive-through subdivision, people wanted to see curb and gutter and sidewalk. And they felt that if they see curb and gutter and sidewalk, then that must be a more influential community in which to live. Fast forward to now, there's a movement called green stormwater infrastructure, where, as you indicated, the goal is to retain as much water on site, use open ditches, and encourage infiltration into the ground, recharging the groundwater table where it stands. There's viability in that approach. There's opportunity for cost savings in that approach. But again, in this community, there was a great deal of pushback. And one of the last slides I showed was open channel conveyance. And the specific reason that I chose that slide was to address just what you're talking about, because the community felt that you want to use open ditches in the impoverished neighborhoods, but you want to use curb and gutter in the influential areas. You know, at some point in time, I don't deny that to be true. But when you're talking about a return on investment to the environment, then it's a complete paradigm shift in the way we approach an engineering solution. So not only do we have to educate our engineers, we have to educate the general public in just the instances that you're speaking of. And one of the questions I'll ask you, if you don't mind, when you spoke about managing it on site, were you talking about managing stormwater or managing sanitary sewer or both?
Both.
Okay.
Certainly, I have been part of probably 10,000 septic systems, and that would be my first choice, which is very little impact if done correctly. And then also managing stormwater as close to the source as possible. And I love your answer that you just gave.
Well, thank you. Well, you know, when you start speaking about septic systems, there's a perception in the community that's diametrically opposed, right? You're right. A properly functioning septic system is viable. But one of the pushbacks that I'm seeing is they're not able to achieve the density unless it's a community system. Now, you can have low impact development where you can concentrate the structures, but then you need to have some open space so that you can have some room to treat your septic system. So very good points, and thank you for being observant to that.
Sure.
And 10,000 systems, by the way, that's a lot of septic systems. So you have some good design experience.
That's a lot of septic systems and a lot of working septic systems, which have, like I said, a very low impact on the community.
Very good. Thank you for sharing that.